So our new topic is fluid. Fluid means a substance which can flow is refers to a fluid. So both liquid and gas are refers to fluid because both of them can flow. Liquid is refers to fluid, gas is also refers to fluid because both of them can flow. Then fluid flows are there. When the fluid like the liquid and the gas move, so there are two ways by which these or the fluid can flow. One is known as a laminar, another one is known as turbulent. So two ways the fluid can flow from one place to another. One is laminar, another one is turbulent. Laminar flow means that the particles within the fluid are following each other. Like example, if these are the group of particles, this is another group. The two groups may move with a different speed, but the particles are actually following each other. So when these particles within the fluid are following each other and move in the same direction, the group of particle, the speed might be different. Like example, this group of particle may have a speed 3 meter per second. This may have a speed 5 meter per second. This may have a speed 4 meter per second. The speed of the group of particle might be different, but all these particles are moving in a specific direction and following each other. So this type of a flow of a fluid is known as a laminar flow. And when there is a laminar flow of a fluid, the fluid will exert less force or less pressure. And what is a turbulent flow? Random movement of the particles or group of particles are not following each other. Example, this is one group of particle, this is another group of particle, and even within the group, the particles have different speeds. So this particle example move towards right, this move straight uh, or move upward here, then this move down. So they are not moving in a specific direction. Randomly they are moving, or we have eddies. So when we have eddy here refers to a random movement of the particle. So this type of a fluid flow is known as the turbulent flow, and fluid exert high pressure or high pressure when the fluid flow is turbulent. So if a question is show a laminar flow, like example, the design of the car or design of airplane is to make it more laminar flow. Otherwise, if it's a turbulent flow, what will happen? Greater amount of energy will be lost or wasted to work done against the force which is opposing the motion. So if we have a sphere and this sphere is moving through the air towards left, this is the direction of the motion of the sphere or the ball. Which direction the fluid will flow? What will be the direction of the fluid flow, left or right? The direction of the fluid flow is towards right. Why? Because the direction of the motion of object and the fluid flow is, because it's, so air will move around it. So as the air will move around it, air is moving in opposite direction. So the laminar flow, if it is laminar, then equal spacing between the streamlines. But if I want to make turbulent, then randomly, So which side of this sphere will move a greater force? Side means which point, A or B? Which point of this sphere will experience greater force from the fluid? So A will experience, because greater force, laminar turbulent flow is there, so that will cause greater force on point A. That is how, like example, say a soccer player or a football player, when he kicked the ball can swing in air. Why the ball can swing in air? Example, if you're looking from the top, as there's more laminar flow from the bottom, from the downside as compared to top, so what will happen? This ball will dip downward. Same thing, a fluid flow can be used for landing and takeoff for the aircraft. Like example, if this is representing the wing, this is representing the wing of the aircraft, and the aircraft is moving towards left. So what will be the direction of the fluid flow? The direction of the fluid flow is towards right. For the takeoff, you will find that the flaps of these wings changes the position. What is the reason? First, when the aircraft is moving at a high speed, so the air is moving around the wings upward and downward. But what happened? The flap will cause the airflow to become turbulent from the bottom. So as the airflow become turbulent from the bottom and it is laminar from the top, so there is a force exerted by the fluid from the top, and there is a force exerted by the fluid from the bottom. But because there is a more turbulent flow from the bottom, so it will experience greater upward force as compared to downward force, and this upward force will help the aircraft to lift up. That's why using the different position, the flaps of this wing changes, which make the airflow become turbulent or more turbulent flow from the bottom as compared to that of the top. So the greater upward force means it will experience resultant upward force, which help this aircraft to lift against its weight. That is why, like example, you don't find that aircraft, if it's stationary, can, like in the beginning, without moving or without reaching a certain speed, there's a certain speed which the aircraft should reach before it take off. It cannot take off at all the speeds. The reason for that, because at a specific, when the objects are moving at a high speed, the airflow become turbulent, and as the airflow become turbulent, and changing the position of these flaps will cause greater upward force and help in lifting of this aircraft. Is it clear? Then we have density. How we define density? It is mass present in unit volume. If you want to calculate the density of the fluid, so we need a mass of the fluid and divided by the volume, we will get it density. The pressure is there, pressure exerted by the fluid. The pressure exerted by the fluid, we have the formula: pressure is equals to force acting on unit area. But in fluid, specifically in liquids, we can use this formula, that pressure exerted by the fluid is equals to density into gravity into depth. This is how we can calculate the pressure. The force which experienced by the object on a unit area is refers to the pressure. Then upthrust, it is upward force applied by the fluid on the object and it is equal to weight of the fluid displaced by object. So upthrust is the upward force which is exerted by the fluid, and that is equals to weight of the fluid displaced by the object. Like example, you have a container and that container is filled with water. It's completely filled with water, okay? And you place this into a large tray and you submerge another object inside this container. So when you submerge this object inside the container, the fluid, the liquid will come out. So how much liquid will come out from the or displaced by the object, like amount of liquid displaced by the object, if you place this on the balance, if this was placed on the balance and the balance is showing 2 Newton. So what will be the upthrust? The upthrust, the upward force will be 2 Newton. So upthrust is actually equal to the weight of the fluid displaced by the object. And how we can calculate the upthrust? As we know, upthrust is not equal to weight, it is weight of the liquid displaced. And how we'll get the weight of the liquid displaced? So weight is equals to mass into gravity. So mass of the liquid displaced multiplied by gravity. And how to get the mass in terms of density and volume? So density multiplied by volume. So density of the fluid, volume of the fluid displaced multiplied by gravity. What is the volume of the fluid displaced? The volume of the fluid displaced is always same as volume of the object. Like if this volume is 2 centimeter cube, the amount of liquid displaced will be 2 centimeter cube. If this object is 5 centimeter cube, the amount of liquid displaced will be 5 centimeter cube. So upthrust is equals to density of the fluid, volume of object into gravity. So whenever we want to calculate, we will use this formula. Is it clear how we form this formula? The upthrust is the force, the reaction force of the fluid. The fluid apply a force upward, or it is always in upward direction. That's why it is upthrust. So, and it is always equal to the weight of the liquid or weight of the fluid displaced by the object. As the upthrust increases, upthrust depends on density of fluid, volume of object, and gravity. So more dense liquid apply greater upthrust, greater volume of a liquid displaced by the object, it will experience greater upthrust. So using this idea, we can also conclude floating and sinking. If upthrust is more than or equal to the weight, then object will float. If upthrust is less than the weight or weight is more, that object will sink. Is it clear, the concept of upthrust? Then viscous drag. What is that? Viscous drag, or also known as a drag force? Basically, the force which opposes the motion of object through the fluid, that is known as the viscous drag, and it is only applied when the object is moving. Like example, if I say object is moving downward, what will be the direction? If object is moving downward is the direction of motion. What is the direction of viscous drag? If object is moving downward, So viscous drag, the drag force will be upward. Another object is moving towards right hand side. What is the direction of viscous drag? So viscous drag will oppose the motion, so it is acting towards left hand side. But if object is stationary, object is not moving, what is the viscous drag here, or a drag force? The force which is opposing the motion. So in this case, the viscous drag is zero because the object is not moving. Viscous drag only opposes the motion. Moving down, the viscous drag will be up. Moving up, the viscous drag will be down. So according to Stokes law state for spherical object, this is only valid for spherical object which is moving through a fluid which is having a laminar flow. So according to Stokes, for a small spherical object moving through a fluid having a laminar flow, that viscous drag is given by a formula 6 pi eta r v. What is eta? This is called viscosity. What is r? R is the radius. And what is v? V is the speed at which the object is moving through a fluid. What is the meaning of viscosity? Viscosity means property of a fluid to resist flow. Like when the fluid will try to stop or resist the flow or does not flow easily, we call this property as viscosity. Like example, if you have two containers, one is filled with water and another container is filled with same amount of honey. Which one you transfer both of them into another container and empty the container? This one is filled with water and this one is filled with honey. Which one you think will transfer quickly, water or honey? So water will transfer quickly, it will take less time, short time, and honey will take more time. So which one is more viscous? Which fluid is resisting the flow or stopping its flow or does not flow easily? So a honey is having a high viscosity and a water is having a low viscosity. But viscosity is not, it is constant at a specific temperature. Viscosity changes with temperature. For liquids, the viscosity is inversely proportional to temperature. If you increase the temperature, the viscosity will decrease. The fluid will flow easily. So if any fluid is not flowing, what you can do, you can warm the fluid so it can flow easily. And the unit of the viscosity is Pascal second. How it is Pascal second? This is Pascal and then multiplied by second. Because we have the formula which, according to Stokes, we have the formula F is equals to 6 pi eta RV. Force unit is Newton, 6 pi is constant, viscosity we are finding, R is a distance, so it is meter, and velocity or speed meter per second. So this second is divided, other side it will be multiplied, and meter multiplied by meter, it will be meter square, then it will be divided. So you can see Newton divided by meter square, Newton per meter square is Pascal, so it is SI is Pascal second. Is it clear how the unit of viscosity is Pascal second? So this is about the fluid flow. A fluid flow can be a laminar or turbulent. Then density, pressure, and upthrust. Then viscous drag, the force which opposes the motion. And using a Stokes law, it is only valid for spherical object. Like if object is rectangular, so object is spherical, then only we can use, and there should be a laminar flow of a fluid, and the object should be a very small sphere. Like object should not be very big, then it will be wrong. It should be a very small object which is moving through a fluid. So next week we'll continue this fluid flow and the topic fluid. Any question related to the class today? Any doubt or a question related to the class? This topic of a fluid is not completed. Next week we will complete. So I'll end the session and share the recording with you.